Hi everyone. Today we are going to learn 10th class mathematics. First chapter, real number. Exercise 1.1. Question number 2. Use Euclid division lemma to show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. In this question, we want to show that any positive odd integer can be written as 6q plus 1, 6q plus 3 and 6q plus 5. But we know that the general form of even integer is 2n and the general form of odd integer is 2n plus 1. Now we use Euclid division lemma A is equal to BQ plus R, where 0 less than or equal to R less than B. Here, A is n positive odd integer and B is 6. Now we apply Euclid division lemma to get A is equal to 6Q plus R, 0 less than or equal to R less than 6. We know that remainder is always less than 2, the divisor. So the possible remainders are 0, 1, 2, 3, 4 and 5. Now case 1, if we take r is equal to 0 and apply Euclid division lemma A is equal to BQ plus R, and we'll get A is equal to 6Q plus 0, and we can write A is equal to 6Q. The common factor of 6 and Q is 2, so we can write it as 2 into 3Q. Later 3Q is n, then we'll get 2n. This is an even integer. So 6Q also in even integer. In case 2. If we take r is equal to 1 and apply Euclid division lemma, A is equal to BQ plus R, and we'll get A is equal to 6Q plus 1. Now the common factor of 6 and Q is 2, so we can write it as 2 into 3Q plus 1. Let 3Q is n, so we can write 2 into n plus 1. So 2n plus 1 is an odd integer, so 6Q plus 1 also an odd integer. Now case 3. If we take r is equal to 2 and apply Euclid division lemma, A is equal to BQ plus R, and we'll get A is equal to 6Q plus 2. Here the common factor of 6Q and 2 is a 2. Then we can write it as 2 into 3Q plus 1. Let 3Q plus 1 is a n, then we can write 2n. Here 2n is an even integer, so 6Q plus 2 also an even integer. Now case 4. If we take r is equal to 3 and apply Euclid division lemma, A is equal to BQ plus R, and we'll get A is equal to 6Q plus 3. Here we expand 3 like 2 plus 1, then we can write 6Q plus 2 plus 1. Now take 2 common from them and we'll get 2 into 3Q plus 1 plus 1. Let 3Q plus 1 is equal to n. Now we'll get 2n plus 1. This is an odd integer, so 6Q plus 3 also an odd integer. Now case 5. If we take r is equal to 4 and apply Euclid division lemma, A is equal to BQ plus R, now we'll get A is equal to 6Q plus 4. Here common factor of 6Q and 4 is a 2, then take 2 common and we'll get 2 into 3Q plus 2. Let 3Q plus 2 is a n, then we'll get 2n. 2n is an even integer, so 6Q plus 4 also an even integer. Now case 4. If r is equal to 5 and apply Euclid division lemma, A is equal to BQ plus R, Now we'll get A is equal to 6q plus 5. Here expand 5 like 4 plus 1. Then we'll get 6q plus 4 plus 1. Now here take 2 common from them. Then we'll get 2 into 3q plus 2 plus 1. Let 3q plus 2 is equal to n. Then we'll get 2n plus 1. 2n plus 1 is an odd integer. So 6q plus 5 also an odd integer. Since 6q, 6q plus 2, 6q plus 4 are even integers, the remaining 6q plus 1, 6q plus 3, 6q plus 5 are odd integers. Hence, prove.